Hey everybody, this is Games Plus James, and welcome back to our Unity RPG tutorial series. Now, in the last episode, we added this little guy here who kind of wanders around. We gave him a very simple little walking routine, but as we discovered, the way he moves, he could wander to anywhere in our whole little world here, which wouldn't be very good for us. So what we're going to do is put some kind of constraints on him. So he can only walk around a certain kind of square area. So what we're going to do is kind of keep it nice and simple, as simple as we possibly can, basically. So first thing we need to do is obviously have an area for him to walk in. And to do that, we're just going to add a new object over here. So we'll create a new empty object, and we'll just call this walk area. We'll keep it nice and simple for now. And all we're going to do is add a box collider to it. So we'll type in box collider 2D. And as usual, we get this little green box around this new object here, and so I'm just going to make this a bit bigger. We're going to make it so that we can kind of let the player walk around, or not the player, let the villager walk around this whole kind of square area here, basically. So I'm just going to move this down here, just roughly like that. So that's the area that he'll be allowed to wander around in. So obviously, if this is a box collider, we don't want it to be something that we can physically bump into, because if we were to press play here now, we'll end up with a really annoying situation where our player's walking along and suddenly we just hit this invisible wall, which is no good to us, and our villager gets kind of knocked to weird places as well. So we need to make sure that our box collider is a trigger, and then what we're going to do is essentially in our villager script, we'll make a reference to this box collider, and we'll get the size of the box. And the way it works to get the size of the box, we can get two different values. There's a minimum value and the maximum value, and that's basically 2 points in space. And the 2 points that they use within Unity is the minimum value starts off in the bottom left corner here, and the maximum value is the top right here. So that way you can know, if you know where the bottom left is here, you know how far you can go over to the left, so you can basically work out everywhere along this line. And if you know up here as well, then you know how far you can go along here, so that way you can work out what the other two corners are, basically. Basic simple maths in action. But yeah, so we're just going to make a simple reference to that now. So let's open our villager movement script that we created in the last episode, and once that's open here, so like I said, we need to create a reference to the area that we're going to walk around in. So we know we just made that as a box collider. So we're going to make a public, I don't know what way I put a bracket there, public, but we can't just say a box collider because the scripts within Unity don't specifically know a box collider exactly. So we're just going to generically say public collider 2D, like that. So we know we're just talking about an object with a collider. And we'll call this the walk zone. Okay, so I'm just going to save this and pop back in here, and we're going to make sure that our villager knows which walk area he's going to be allowed to walk around in. And the reason we want to do this is because we could have multiple villagers walking around, but they'll all be able to stay within the same kind of zone within the world if we do it this way. So rather than having to go and specifically say this villager can only walk around a tiny little zone, we're making this kind of generic zone that lots of different villagers could potentially walk around in. Okay, so we've got a slot here for our walk zone, so we're going to drag our little walk zone box there into there. And now we need to actually do some things with it. So if we're going to we'll want to be able to keep track of those two minimum and maximum points of the box. So we're going to create two private vector 2s that we'll call min walk point, and we'll call max walk point. Nice and simple. And so what we want to do is set those two values straight away. So we're going to set them in our start function here. So the way we could do that is just by saying, so our minimum walk point is equal to our walk zone, and we're going to do a thing called getting the bounds of that. So we're going to say walk zone dot bounds dot min. So that will get the minimum point on the boundary of the walk zone. So the boundary is on our box collider object. It'll get the boundary of that, and it'll get the minimum point. As we discussed, that'll be down in the bottom left corner. So we can do the same with our max walk point is equal to walk zone dot bounds dot max. So that way we can have our two different points in space. We have our bottom left and our bottom right. So now we can work out the exact size of where our player walks into. But what if we wanted to have our villager be able to walk wherever he wanted? We could create an extra script for doing that. Obviously, it would be an awful lot of work, kind of unnecessary work. But what we could do instead is basically say, if we don't assign any kind of walk area to him, he's free to walk wherever he wants to. But if we've given him a walk area, we have to use these bounds. So what we can do is just add a little if statement around these two little points we're setting, and just say if our walk zone is not equal to null. And then we'll put our two brackets around these lines here like that, our two curly brackets, and just kind of indent them in just to keep it looking a bit nicer. So what we're saying here is, as long as our walk zone has something in it, then get the boundaries of it. If our walk zone doesn't have anything in it, obviously we wouldn't be able to get the walk zone. Or we wouldn't be able to get the boundaries if there's no box collider to get the boundaries of, and we would actually get an error. But what we're saying here is, okay, if there is no box, we don't need to worry about it because we're not actually going to do anything to handle that. So now that we have our boundaries worked out, what we need to do now is basically do a check for whenever our player is walking left, right, up or down, and do a check if they're outside the boundaries. And if they're outside the boundaries, we just basically tell it to stop moving. So what we'll do is, just in each direction, we'll just do a check and see if they're going the right way. So what we'll do is here, we have to also check that our walk zone is actually active. So what we should actually do is have a Boolean value that we're keeping track of to know whether we have a walk zone active in the world. So we'll add an extra bool here that we'll call, we'll just say private bool has walk zone. Nice and simple. And that'll be, by default, that'll be false. And then here we're checking if we have a walk zone. So if we're able to get the bounds and stuff, then we know, okay, so we definitely have a walk zone, so we can make that be equal to true. And the reason we want to use this bool value is so that we're not doing a check every single time to see if one of our slots is null. It's a lot easier to just do a check and see if a value is true. It's a slightly more processor intensive check to do and see if something is null, but not excessively so. But anyway, it's just kind of one of those good habits to get into. So in our walking thing here, so we're setting our move speed, so we're going in different directions. Our case 0 is when we're moving up, as we remember from last episode. So basically what we want to do is check if we actually have a walk zone limit. So if has walk zone is true, and the next thing we want to check, because we know we're moving up, we want to check if we've gone above the top point. So if we just have a look here again, what we would know then in that situation is we're dealing with the top point here, so that's our top right point, and what we want to do is check if the player has gone above the Y position of this point. So the X position will be going left to right, which would be kind of talking about this line here, but then the Y position is going up and down. So if our Y is greater than the point here, then we know our villager has gone too far, so he has to stop walking. So what we can do is say, so if we have a walk zone and our transform dot position, if that is, transform dot position dot Y, if that is greater than our max, what did we call? Max walk point, yes. Our max walk point dot Y. So we know that our max walk point is a vector 2 and it can only have an X and Y. So if our transform position is greater than our max walk point, then what we want to do is tell it to stop walking. And how we do that is, of course, we use the same thing we're doing here, where we're setting our walk to be false, and we're setting our wait counter to be equal to wait time. So we'll just copy that same little bit there, paste it in like that, and there we go. That's how we stop a player walking up when they go too far. So we'll do the exact same thing now for the other directions. We'll actually just kind of copy the same lines of code, paste that in there like that. So now for case 1, we're moving right. So instead of doing the transformed.position.y, we'll do transformed.position.x. We're still dealing with the max walk point because that's the top right value, but instead of the y one, we're doing the x position. So that's how we know, again, our player should stop walking. Then on to case 2. Case 2 is where we're heading downwards. So obviously we're going to be talking about the min walk point this time, and min walk point.y. So our transform.position.y, but now instead of checking if we're greater than that position, we want to check if we are below that position. So if the transform position.y is below the minimum walk point, then our player should stop walking. And then finally we have, just copy this one more time, paste it in there. So now we're going to be doing our check, because we're doing our movement to the left, which is case 3. We're obviously going to check our x position moving to the left, and that it is, if it is less than our minimum walk point .x, then stop walking. So we'll save this and we'll head back into the game, and I'm going to just increase the villager's movement speed so that we can hopefully see our walk area taking effect. So that's not that much faster. Let's try movement speed of 5. Hit play here. I'll switch back to the scene view so we can see our guy moving around. We won't have him wait at all. So at the moment he looks like he's kind of getting, he is stopping, but he's actually just, his movement is trying, there we go. So we saw he got moved to the, he's moving to the edge of the box now, and whenever he gets to the edge he kind of stops and he changes to a new direction. So there you go. If I just switch back to our walk area, you'll see because of the center of the object itself is kind of here. It's not necessarily the player or the villager isn't necessarily just getting stuck exactly at the limits of the bounds, but he's getting stuck at essentially close enough. So there you go. That's how we can kind of put a constraint on our villager so he's not able to just freely walk all over the place. We're giving a bit of a container zone to be staying inside of. And it's a fairly handy thing to be able to reuse. It's good to be able to use for enemies and stuff like that. So if you're using this kind of walking routine, as we discussed before, you could easily use this whole villager movements for your enemy movements in the exact same way. But I'll be back soon with more RPG tutorial goodness. Thanks for watching this episode, and I'll see you all very soon. Thanks for watching this episode, and if you want to learn more about developing your own games, you can follow the link on screen to my complete 2D platformer game development course on Udemy, where you will learn how to program and build a complete game in Unity 2D with multiple levels, enemies, and unique boss battles. So click the link on screen or in the description below and get the course today.